So again, the addition property of equality. Now, this doesn't have a super wordy definition that I'm worried about you knowing, but what we do need to know is that if A equals B, then A plus C is equal to B plus C. If I start with two things equal, I can add C to both sides and maintain that equality. Now, right, I can already sort of give this away a little bit. We can see the addition property of equality and the multiplication property of equality. Notice that we do not have subtraction and we do not have division. The reason for that is adding a negative is the same thing as subtraction. That's the note I really want us to know. We can always add a negative, and it is the same thing as subtraction. That is why it does not get its own specially named property of equality. Now, we're actually not going to define multiplication right now, and instead we're going to look at examples of addition, the addition property. Once you have this, flip your notes. Good, good. Over there. All right, example 1. Pretty simple. We need to solve for x. Now, help me out. If I'm looking to solve for x, raise your hand. What would I do on both sides? Anthony.
Subtract plus 2.
Say it one more time.
Subtract plus 2.
Subtract plus 2. Yes, I'm going to change the wording ever so slightly to just subtract 2. Now, before I even get to an answer, again, I want to see a raised hand. How did we know that we had to subtract? What told us that we actually needed to subtract in order to solve this? Janiyah. Louder. The addition sign. If I'm trying to get x alone, do we remember the vocab word for getting x alone? Charles? Louder. Isolate it. We want to isolate x here. That means I have to get rid of that plus 2, and because it's a plus, yes, we should be subtracting the 2. And so I'm going to have x equals, well, everybody, 10 minus 2 is?
8.
Careful, 8. Far side, I'm real done with giving warnings. Example 2. I have x minus 3 is equal to 8. Again, I want to solve for x. Yes, I have to isolate it. Raise your hand. What am I going to do to both sides? MJ. Plus 3. X is going to be equal to, everybody, 8 plus 3 is?
11.
There it is. 11.
So I got a question. Why you can't just do like 8 plus 3 and then you'll get 11? Why you can't do that? Why you gotta do plus 3 on both sides?
So, great question. Carol said, well, why don't we just do 8 plus 3? Why do we have to do plus 3 on both sides? Did I?
Because you got an income negative 3 up there.
Yeah.
I mean, but what if you already know that you just do like that's what I did on the first round and I got the same answer?
So you're saying, why am I writing plus 3 on both sides?
Yes.
Because, let's go back. Property of equality. If A equals B, then A plus C equals B plus C, right? This is the mathy way of saying, whatever I'm doing on one side, I have to do on the other. In math, it is a cardinal rule. I cannot do something only on one side. And so in our line by line, yes, I need to see it happen on both sides to show that you know that. All right, and then down below is a small box for a key takeaway. In that key takeaway, we're simply going to do addition and subtraction are inverses. Again, inverses or inverse operations we will stamp fully tomorrow, but for now, they are operations that undo one another. Addition and subtraction, those are inverses. Once you have that key takeaway, put pencils down so I can see, please. Thank you. We're there. Thank you. Very fast, thank you. Tay, just make sure your head comes up, please. All right. So with that, like I said, we're actually going to pause on the multiplication. And so I actually want you to jump back into your packet and go to problem set A.